Honorable Director, Management of Resources and Budget, Director, School of Management Studies, CUSAT. She was a member of Academic Council, CUSAT, member of Senate of CUSAT. Welcome you, sir. Hello.
Yes, I'll just share and then start presenting. Am I audible?
Yes, sir.
Audible, sir.
Are you able to see my screen?
Not yet, sir. Yes, sir. Yeah, now it's visible, sir.
Okay, thank you. Welcome to all the participants once more. I will just take you through a talk on the role and importance of technology management. Management of technology, that is how it is also referred to, is an interdisciplinary field that integrates the areas of science, engineering, social science, industrial practice, and business theory, besides some other smaller areas also. So please remember, it is a multidisciplinary discipline. MOT can be thought of at two levels: macro level, a field of knowledge that is concerned with setting the implementation of policies to deal with technological development and utilization of technology on society, organization, and individual level. So it's to do with policy making regarding technology. In the second thing, which is at the micro level, it is an interdisciplinary field which is concerned with the planning and development and implementation of technological capabilities to shape and accomplish the operational and strategic objectives of an organization in the creation of competitive enterprises. That is, for the individual or organizations to remain sustainable and grow, what is done, that is at the micro level. Technology, as we understand, is an essential input in production of goods and delivery of services. It could be defined as the knowledge, the product, the process, the tools, methods, and the systems employed in creation of goods or in providing services. Technology can be subdivided into technology, that is soft technology, and hard technology. Hard technology is embodied in machine and equipment. Look at this MRI scan machine. A lot of technology is embodied in that machine itself. Soft technology is the know-how and information that is disembodied, that is removed from the hard and is to be available with the users and the processes. For example, in the CAT scanner, how to put the patient in, how to dress that person, what are the articles to remove from the body. These are related with process, how to analyze, how to interpret the scan. They are the soft technologies. There is another classification of technology, product technology, which is all the knowledge that is used to produce a product or a service. It consists of process technology also. Process technology is the method or the ways to transform the inputs to the output or to provide the given service. So the process of giving the service. Product is there, the service is there, and the process technology of how to. And of course, the management technology is how to manage a system which uses this technology to deliver products or service. That is the management technology. The components are the technoware, which is like the 3D printer, the technology, the humanware, the person embodied with the human abilities, skills, and knowledge, like the 3D printer operator that you see in the picture. Infoware, the steps of doing the printing, which you can see in the model, which is in the model specification, manuals, infoware, and the organware, which is the organization, embedded into the organization. Why do you need to look at in such detail? Because there are certain things which is more patentable and certain things in this technology components which are more difficult to patent and to acquire, to transfer. Transferring and acquiring these technoware is easiest. Next easy is the infoware. Still more difficult is the humanware. Most difficult is the orgaware. Technology is also qualified. New technology is introduced or implemented, and that has an explicit impact on the way the company produces goods and delivers its services. There are different names given to different types of technologies. You will hear the term emerging technology. Emerging technology. I have chosen IoT, Internet of Things, as an example for this emerging technology. It is a technology that is not yet fully commercialized, but will become a new technology within about 5 years. So that is an emerging technology. Another term you will hear is appropriate technology. That is an optimally used technology indicated by a good match between the technology and the resources that are utilized and its sustainability. I have used solar power, solar panels as an example for that. Then there is high technology. High tech, that is how it is called in short. Some of these characteristics are, it employs highly educated people such as scientists and engineers. It uses automatic and sophisticated operations. Its technology is changing at a faster rate than other industries. It competes with technological innovations. So in that area, a lot of technological innovations take place. And it has high level of R&D expenditure. As an example, I have put a virology lab for coronavirus development, vaccine development. It's a high-tech area with the characteristics that I have shown in my slide. Then there are also, I continuing with technology levels, high-tech, low-tech. Low-tech refers to simple technologies that have permeated a large segment of market, that is, has gone into the market, spread out, and utilized. It is utilized by the company. An example I have taken is a bread manufacturing unit and the technology available for bread making. It employs people with relatively low education. It uses manual or semi-automatic operation. It has low level of R&D expenditure. Its technology base used is stable with little change. Its products produced are mostly of the types that satisfy human needs, more basic human needs. Medium level technology comprises of a wide set of technology that falls between the high and low technology and usually refers to mature technology. Once it might have been high tech, but now it has become a mature technology and that are more amenable than other technology. Amenable means easy to use and easy to apply. In the automotive industry, we have technologies, many of the technologies like that. Some of the technologies in automotive are also high-tech. It employs people with good levels of education, uses semi-automatic and automatic operation. It has medium levels of R&D expenditure. It's technology-based, use is matured. Technology is mature with slow change. Its products are produced mostly of the types that are meeting either consumer needs or industry needs. Now, we had looked at the different levels at which technology might be used, different level of technologies which might be used by different companies. Now, let us look at the capacity of companies to absorb or take in technology, which is important, which has to be assessed as an appetite for technology. Acquisitive capability, acquiring capability to acquire technology is the ability needed to acquire and use technology based on instruction and training provided by the supplier. This is a very basic capacity. If this is not developed, when one cannot think of technology transfer, use of technology borrowed from, even from your R&D lab to your factory, you will fail if you don't have this acquisitive capability. After acquiring it, following the instructions of the suppliers, using the technology, one has to have the next level of capability, which is called the adaptive capability. Adaptive. Tinker with the technology, adapt the existing technology to suit more your own requirements or your customer requirements, your manufacturing process requirements. That is the adaptive capability. Innovations are coming after that. This was just tinkering. Innovative capability is at a higher level. Is the ability to develop existing technology and create new technologies based on research. So take the technology to a higher level, distinct from what it was in the beginning. That is the capacity to innovate. So if you have a capacity to innovate, only then you can become self-sufficient after buying a technology in the beginning. You can innovate and take it to different levels. Otherwise, a company, organization will be always dependent on someone else for technology. Then there is the R&D capability, research and development capability for producing research, useful research output to improve the organization's business through customer satisfaction. R&D capability of an organization. That's also an important capability. That coupled with innovation, innovation on the floor is usually tinkering. It is more of adaptation. R&D only helps in innovation, which is big. Then there should be capability to invest, investment capability to analyze the feasibility of different technologies and to try and acquire, invest in the appropriate and right technologies. Last, marketing capability. If you are a technology company, meaning a lab which always only produces technology, you patent and you don't manufacture using the or produce services using your technology, you sell that technology. So if it is an organization like that, then capability of marketing your technology is also an important capability in technology management. Let us now try to understand the difference between invention and innovation. Two terms very often used in the discussions on technology. Invention is the creation of a novel technology. It could be a product, a process, or any unknown system. See, the electric bulb, big one. Yes, it could be, it is classified as an invention because it did not exist prior to its creation. Obviously, discovery, you are all aware about. Discovery is, it existed, but it was not understood in that form. So, discovery. So, you discovered a new species of spider. Spider was already there. You did not make it. It was not found out and revealed, identified and revealed to the scientific world. So that is what you did. It was a discovery. Discoveries are more related to pure science. In technology, we have inventions. Innovation involves creation of a new product, process or service to an organization and introduce them to the market by utilizing and commercializing them. So innovation is to use technology and take the technology through process or product to the market. So innovation is more related with providing product or processes using technology to customers. There are, as literature classifies it, incremental innovation and radical innovation. Two terms are used. Incremental innovation involve adaptation, refinement, and enhancement of the existing product or service. For example, you made a new chip, which is faster, works faster than the earlier generation. So it's an incremental innovation. I have put most fuel efficient car. So there were cars. You made a car which is more fuel efficient, but it uses the same fuel, same technology, but its efficiency is higher. So that's an incremental innovation. But the car below that you see, which is an electric car, is a radical innovation. Because the source of energy, the mechanisms used inside for providing the drive control are different. So that's and though both are cars, the fuel efficient car is just an incremental innovation and the electric car is a radical innovation. Now let us look at what is the interaction between the market and technology. Market or the society and technology, what are the forces which play between them? There are two forces. One is called the market pull, the other is called the technology push. Market pull and technology push. The market pull is the market forces that apply, are recognized, means demands, needs, or unexplained, unexplored needs, because market might not be asking for things, but there is a latent demand, hidden demand there, need, which is recognized by the organization and R&D. So this market demand is recognized by R&D and technology development takes place and technology is produced, which is used for production of goods or services which go into the market. So it's all started with analysis of the market and understanding of a need for certain technologies. That is called market pull. Technology push, on the other hand, is you are working on one line of technology development. One line of technology development. And, for example, on nanomaterials. And then you come across a technology through your research. You come across a technology, and then you find that you can make products or deliver services using that technology. You do it, and it is taken into the market. So the demand, the need is created by a product based on technology which is pushed into the market. So, for example, our mobile phones, we had telephones, we had mobile phones of not the smartphones, the earlier first generation mobile phones. And even if the new ones did not come, the civilization would not have perished. Society would not have deteriorated. So there was not that need to communicate is there, need to communicate multimedia and all those is there. For example, even now, we have a need for teleportation. What is teleportation? Me to move from here without really traveling to reach somewhere in a few seconds. So those kind of needs exist, but then that is not called a market pull. It was a technology push. These mobile companies came out with these products, and the products came to market. People lapped it up. New generation started coming. Mobile development has taken place through technology push primarily. We have certain other things to look at. In this, you can see a technology innovation chart. That is, they start finding of a technology, then on the curve, it slowly grows fast, and then grows fast, and then matures, and then declines. This curve is not drawn further. If you draw further, it will decline. And for example, if this is a current technology for mobile phones, for example, mobile phone battery, and a new technology comes up at this stage for better batteries, and that technology comes and it is slowly growing. These are called S curves. These are called S curves of technology, where many S curves will come. And one curve has an effect on the previous curve. For example, coming of a new technology. In fact, coming of this, smartphones rang the death knell of Nokia. Nokia, which was a biggest phone maker, mobile phone maker, at the biggest market share, did not believe that the gadget called smartphone would be very useful. They thought rugged phones with this keys are the solution. That is what will remain forever. They did not go into that technology, and the whole company came down, lost its market share to players like new entrants like Samsung. Because a new graph, a new technology came in, and with which they took the market, went above the previous. So one has to understand this, and this is understood at the time in the activity what you call technology forecasting. There's an activity called technology forecasting. Anything which it has to be managed, you have to understand the current state of affairs. You have to understand the history. You have to understand the current state of affairs, and you have to try and predict what is likely to happen. For managing a phenomena, you'll have to learn from history, understand the current status, and predict into the future what is likely to happen. Only then you can choose an appropriate course of action. So S curves helps us do that. This is the technology life cycle chart, which is drawn on this axis, the y-axis. You can see the business gains, the gains that you get out of the activity. On the x-axis, you have progress of time. On the y-axis, you have the business gains. Above zero, you have the positive gain, or you are contributing or you are making money. And below you have the axis, which shows that you are spending money, you're losing money, you're putting in money, investing, and above the axis, you are the time when you make money. So in R&D, understanding this graph is important. You have to first spend a lot of money without making anything. You have to spend a lot of money without making anything. Only when you start commercializing, you will make money. Till that time, you will not make any money. And there is another thing to remember. There is not all your R&D projects will successfully reach this stage. Meaning, you start the R&D project, it will reach this, then slowly you'll start making some money so that the R&D expenditure decreases, and then you're starting to sell products and you're starting to make money. This does not happen for all R&D projects. Only around 10 to 20% of the R&D projects in a very area like a pharma company, pharma R&D also make some money. And the star are very few. Stars means makes a huge amount of money. They are very few. Star projects are very few. So the projects on which you lost money, did not make any money, also should be covered by the projects which you made money, some money. So two things. If this is too long, this time in which you are doing R&D, if it is too long, then it will obviously take more money. Plus, you stand a risk of entering the market late. You stand a risk of entering the market late. So if you enter late, what happens? Some people have already taken a good amount of market share. And also, you have to understand a little of marketing and management also. What happens in this kind of new products is you skim the market. Skim the market means, skim word comes from milk has the cream on the top after boiling. So instead of taking the whole milk, if you want the cream first, you just skim the cream off first. So if you look at the Apple iPhones, when a new one is launched, it is launched at a very high price. It stays for that price for a couple of months. So the people who are that market, which is willing to pay that price and acquire that phone, it is exhausted. They are given the phones, they say limited edition, this, that, and sell it to that person. People the same phone, which I'm going to get after 1 year at half the price, will be sold in the first 6 months at a very high price. And that revenue will come. Later, slightly lower price to the next batch of people, and so on. Apple does not come too low. By the time it launches a new model and takes us through the same cycle. So this is what is also there. And there are different stages at which initially a big growth, then the maturity I talked of, and then the technology, sales from the technology related products start declining. And at some point, if you want to elongate its life, if you want to elongate the path life like this, you have to do some innovation. And that also, not incremental innovation, innovation which is drastic. If you can do that, you can get a little more elongated life for that product. Otherwise, that product will, with the technology, will decline like this. So understanding this technology life cycle is important. You have to understand which technology is at what stage of life. So technologies that are on decline, you should not buy because they don't have too much. Technologies which are just here, you don't know whether they will ever come here or not. So there is risk in buying. This stage, there will be some teething problems. You will have to solve that. and then only it will go to a big height. If you can't solve the teething problems in this level, then the curve will go like this and fall. Hope you have understood some things from this technology life cycle and the strategy to be adopted in managing this life cycle. This commercialization is also in just the line above in the previous slide, the line above this is expanded. This line is expanded. This line, the R&D has been removed. This is expanded in the next slide. Time or investment on the x-axis. On the y-axis, some performance factor of the product. Performance usually is low when the product starts, and then you improve the performance a little more, and you can make it reach a stage where it is commercially acceptable by the market. Once you can reach that stage, you will launch the product. Then it goes into the market. Stage 1 is the stage in which you're testing the test marketing only. You're not commercializing, you're test marketing, finding out, prototyping, test marketing, and trying it out. And then first commercialization happens. When it goes into the market, you get a lot of feedback from market. You get feedback from people who are servicing your product, and a lot of rapid product improvement has to be done. You improve, your competition also starts coming in, proliferation of the product happens. That happens fast, and a lot of things have to be done in a short time during this stage. Stage 2. After the product has been stabilized, then you look at process improvement, manufacturing process. Why? At this stage, the product and products reliability, ability, performance was most important. Later, as it nears maturity, like I told you, you have to go to customers below. Your top paying customers are all over. You have to reduce cost. You have to go into volumes. Then the process improvement, manufacturing processes, raw materials used, all these things have to be done. And then you will have gains there, and stability also of the product will improve. Stage 3. And stage 4 is the cost reduction through business means. Business means negotiating, bringing down the cost of your raw materials. Raw material is not changed, its cost is changed. Giving lesser margin, but asking the dealers to do more volume. So trying to do things like that in the first stage. And that is what you keep at the time of maturity. Decline. At the time of decline, what you have to do is try to reduce the speed of decline. If you can't make the decline go up, you can make it go up by moving the product to different geographies or to different market segments where your product did not exist. When all that is done, that is the size of the market you try to increase by increase the geography and the reach and the number of customers available in the market. After that is done, you have to try to slow. There are product technology strategies like what Apple does, like what IBM does, what Intel does. They use the next wave of technology to deliberately kill the previous level of technology, so that users of the previous product migrate into their next product. So that's a very good strategy which is used. That is, our new set of product is used and launched at a time the other thing is likely to decline so that it is killed and the company keeps making money all the time. In another interesting phenomena to look at in this technology management area is technology behavior of organizations. Technology behavior of organizations as well as peoples. See, there is this first segment called innovators or inventors or all those people who do the R&D, who make technology. They are very few in number. And then they push it to the adoption stage. Adoption. They try to commercialize and make products or services out of the technology that they have invented or innovated. There is this chasm or a big valley in between, the valley of death. In this valley of death, a lot of technologies which were just born, products which were born out of new technologies, they perish in this valley of death. Only those technologies which could come over here, not falling into the valley of death, will be taken up by early adopters. Early adopters? Are you another early adopter? Just try to think of it. There are problems, there are gains for early adopters also. Because early, you don't know whether this is chasm, where this chasm is and where it has come out or not, you don't know. You can be an early adopter taking this technology also. So after some time, the technology goes down, the product is not withdrawn, it is no longer available, its parts are not available, you fall along with the technology into this. So early adopters, the advantage is if they can get a good start, if their choices of technology were right, they get a lot of advantage. In terms of the technology also, they can buy at lower cost because there is more risk, you can get a good bargain here. Early majority, after it has become adopted by early adopters and their reviews have come, there is an early majority which adopts the technology. They are the largest chunk of people who operate in the technology space. Early majority. Then comes the late majority. The late majority wait because they have want to be certain about the technology and they want a bargain again. Because when the early majority starts declining, it is when the late majority join, and they join because of the bargain they get in the offer regarding the technology. And then last are the laggards, late joiners. They come in towards the end, and they are always the losers because they should not have joined. Because after joining, they are able to use the technology for a very less time, because after that time, maybe getting over and a new technology could come. So one should understand this technology adoption cycle also and its impact when we are making technology related decisions. I just put this slide on technology product development, and this is for a healthcare product, personal healthcare product by a German company. It has said that it takes from 18 to 24 months. So from ideation to the product being ready to go into the market. Ideation interacts with market analysis, with consumer research, and produces what is called an industrial design. A lab design is different and industrial design is different. Industrial design has to interact with sourcing and engineering. Sourcing and engineering, because the product design has to be manufactured. So it interacts with engineering, it interacts with sourcing. The raw materials are required for that producing the product. Are they available? Sourcing, and then the industrial design is finalized. The engineering interacts with obviously sourcing, industrial design, and with prototyping, producing the first working part, and with production support to make the product available. Meanwhile, sourcing also interacts with retail experience, and there is the creative, structural, packaging, naming, graphics, all those aesthetics and many functional things, including manual, how to put that. All these are done parallelly. They interact with consumer research and structural packaging. And they go, packaging design, packaging is over, the product is ready, the marketing people are there, so the product is sent to the market. This is what has to happen. And up to prototyping and making the product available, usually the problem which is faced by many industries is the research scientist does not leave his or her lab. It's not willing to step out of the lab, and therefore does not understand the problems which would come in industrial design. And industrial designers have not stepped into the R&D lab. So they don't know how to innovate and solve the problem. This is where a lot of time is lost in identifying problems and quickly finding solutions. And a lot of time is lost there. A lot of iteration takes place here. Once engineering design is done, industrial design and engineering people have done the process design with the help of production support, manufacturing happens, and only a few teething problems are remaining. At this point, let me tell you about a very important quality related rule. It is called the 1-10-100 rule. It is called the 1-10-100 rule. It is related with problems in a product. If there is a problem in your product, if there is a problem in your product that you can detect at the design stage and solve it, you detect the problem at the design stage and solve it, you incur $1 for that exercise. You incur only $1 for that exercise. However, if you miss that opportunity, you don't catch it at design stage, it goes into the manufacturing stage, then you will spend $10 to rectify the same. Hello, I'm in a class, ma'am. I'm taking a class now. You will spend $10 to rectify the demand if you catch it while manufacturing it. Means same defect, you catch it while it is being manufactured. But even then, if you could not catch it and it goes into the market, it goes into the customer's hand, and then the defect shows itself, you will spend $100. So it is best that you try to catch as many defects, errors in the design phase as possible. And that is not usually easy, but all attempts should be made in technology development to catch all product related issues that might come up by discussion by brainstorming, by thinking, and by trial, test marketing also at the design stage. I will present some of the areas of technology management in which work happens. These are not exhaustive, these are only illustrative. One area of study is technology strategy and planning. This is at macro level and industry level also. Technology strategy. Do you want to be an early adopter? You want to be a laggard as far as technology? Are you in a high tech? If you are a high tech, you can't afford to be a laggard. So these kind of strategies and planning. Then management of your R&D. How to fund your R&D, how to manage people, projects, what projects to take up, all these is an important area of technology management. Financing for technology. How do you find money to finance your technology initiatives? An important area. Managing intellectual property is an area which is very important. Only then the technology remains yours, otherwise it can be taken by everyone. We will dwell a lot on this. Technology assessment and valuation. If you are looking for and buying technologies, you will have to assess different technology choices and you'll have to value so that you can decide how much you can pay for it. If you're selling also, if you're creating technology and you want to market it, you should again assess and value it so that you can decide at what price you will sell it. Technology forecasting, very important for technology strategy and planning. And also for R&D, what technologies search to invest in, what R&D to invest your time and money in, and so on. Technology acquisition, that is acquiring technology, acquiring at an organization level, how to acquire and use a technology. Using technology, you come to technology transfer, the legal parts and the process parts of technology transfer, adaptation and innovation of technologies that you are using or you have transferred to yourself. And last topic I have put is managing technological disruptions, which is a very important area of technology management, which is now gaining a lot of attention, managing technological disruptions. I have given you an introduction to the area of technology management and drawn a small picture which covers some of the areas of technology management. I conclude here. If you have any questions, I had to go a little fast because of the time disruption which was created, the other talk creeping into 35 minutes of my time. So I conclude here. On the technology proficiency scale, there is a technophobe, person who's afraid of technology, the technophile. So we are on different technologies, we are at different levels. But then one could, and familiarity and fear comes out of knowledge. When it increases, more familiarity comes and you are more comfortable. I conclude my talk. I wait for any questions if they are there.
Yeah, the forum is open for questions. So if you have any questions, probably we are running short of time. So how IPR can boost technology revolution?
Yes, I'll see if your intellectual property earlier, before the IPR regime, you had to keep it as a secret and protect it. Now, in an industry where you have to use the technology to manufacture products and services, you have to, understanding of the technology will have to be shared with many people. And in course of your business, many people will know this technology. And if they take it out, that knowledge, keeping that secret formula in your pocket, that kind of thing cannot work in many areas. So, with the coming of IPR regime, where there is a legal backup for your technology rights, where you can claim that this is my invention and you can get it patented, and your patent is protected legally for a time period, that encourages, has created a setup where there is encouragement to create more technology, to share it through licensing and other legal means, and make money, commercialize and make money. So that is what has given encouragement to R&D. That is how IPR has given, protection has given encouragement to R&D.
The next question is from Sridevi ma'am. Due to pandemic situation, how to make use of technology at best level in higher education? Will it justify students?
See, aren't we doing it already now? Aren't we doing it already now? How well we are doing it? That is okay. That is a question. That is a question. Is it the best way? But given the constraints, isn't the society, isn't India, aren't we all moving, adapting, learning to use technology? And Sridevi ma'am, after pandemic is over, won't you continue to use some aspects of this technology that you have learned for conducting classes, for conducting quiz? Won't you continue to do so? I think I will. Because learn new things and find that they will remain useful even when this tamp down on meeting, getting together gets over.
Okay, sir. I think we have no further questions. So I'll propose the vote of thanks. It's my duty to propose a vote of thanks. May I request kindly all of you to mute your
Just a
microphones?
minute. There is one question on which I would like to. When technology product advances through R&D, does IPR need to be revised? See, if that question, I will just take a small take on that. If it is significantly different from your earlier one to enable you to file another patent, you should file. Only then you will protect it. So that is why if you look at patent literature, you will find nearby patents. With a gap, they are nearby. Why? Because by just putting a patent in one area, you can't claim the whole area. What is not described in your patent is out of its preview. Always remember that. Thank you. Dr. Radesh, please go on. We'll conclude.
Yeah, thank you, sir. So it's my duty to propose the vote of thanks. Thank you, first of all, sir, for coordinating the program. And it indeed was a primer we are planning on management. I believe since we have a diverse participation from various fields, this probably will the participants an overview of what basically the kinds of technologies are and how basically it is managed. Thanks a lot, sir. So we'll break for lunch and we'll resume at 8 p.m. With the next session by. So request all of you to kindly get back by 2:05 or 2:10. Thank you.
Thank you. The slides will be shared. Don't worry. Slides will be shared.